Okay, so today we're going to talk about Vyper. Hello, everyone. So I guess one cool thing would be to understand like everyone's sort of familiarity. So who here has used Vyper before? I'm just curious. That'd be really cool if no one had, because now I can like shill Vyper to the world. So I'll let those questions come in. And we've got some nopes. Ooh, very exciting, very exciting. Excellent. Okay, well, that's cool. That's, I think, even better because you guys won't know when I say wrong things. Ha ha ha, just kidding. Excellent. Okay, so let me talk about what I'm going to do today. Okay, and Jing says she wants to know more about the plasma contracts. Woo, well, that's good. So yeah, maybe it's a bit of background. My name's Ben. I work at an organization called Plasma Group, and we have built a open source Plasma implementation in Vyper. Of course, only the contracts are in Vyper, so the rest of the stuff that you need to do, you know, like the clients and interacting with the Ethereum, the wonderful Ethereum blockchain, has to be done elsewhere. So oftentimes in Vyper, because Vyper is built to be a Python-like language, that's done in Python because that just makes sense. However, it may be the case, as was the case for us, that you want to use JavaScript when you do that. We thought that JavaScript would be more accessible to open developers. It's also friendly for things like you know, integrating with mobile applications and things like that. So we found ourselves in a case where we wanted to use both. So what I thought I would do today would be to show you guys our Plasma contracts that were written in Vyper and go over how we integrated them with JavaScript. Does that sound good to everyone? Cool. Okay, so let me go ahead and share my screen so we can dive into what that looks like. Okay, screen share. Here we go. Ba-boom. Wonderful. Okay. Can you all see this? Let me make sure I have the ability to view you guys' chat right now. Okay, more chat. There we go. Now I can see you guys talking at the same time as I show you my screen. Okay, very cool. Okay, so here we are in the Plasma Group GitHub. So we have a whole lot of fun stuff in this repo, but today we're going to focus on Plasma contracts. This is the repo where we have all the Vyper stuff. So you can see here, you know, we've got like a standard README. Basically, we're going to go through some of the requirements and setup that you see in this part of the README, and dive into this very fun integration between Vyper and JavaScript. Cool. Okay, so the first thing that I'm going to do is I've made a fresh folder here on my terminal called EDCON Workshop. And so what I'm going to do is I'm going to git clone this repository. So let me copy that link and let's git clone it in. Okay. So as I'm doing that, maybe I'll just talk about in words what we need to accomplish. So the one thing that we need to be able to do is we need to be able to compile Vyper, right? So in smart contracts on Ethereum, everything is actually expressed in EVM in this horribly complex, contrived, you know, set of binary called bytecode. And so to deploy a contract to Ethereum, you need bytecode and something called the ABI, the Application Binary Interface, which lets other contracts talk to the bytecode. But of course, Vyper is a higher level language. And so the point of languages like Vyper and Ethereum are to compile downward into bytecode. So we've done a few things with this repo. One of the things that we've done is we've created a way for people who are working on the Vyper to have to be able to do that. But if people want to use this repo without having Vyper, just with JavaScript, because the rest of the tooling is written in JavaScript, we can do that. And so the way that we've accomplished that is if you see here, there's a compiled contracts folder. And in this compiled contracts folder, you'll see a series of JavaScript files, which if you open them are nothing more than, what do you know, bytecode. So basically what we've written is like very simple tools that allow you to compile the contracts down into this bytecode and ABI, and then pull them into the wonderful world of testing. Okay, but why don't we start with the Vyper? Because if you're here today, you probably are more interested in doing the Vyper stuff. Yeah, so we'll start there. And any questions as I go into this, please ask in chat. I love when we get to talk. That's just the funnest thing. Wonderful. Okay. So here we are. We can see now that we've cloned the Plasma contracts folder in the EDCON workshop folder. So let's go into that. Wonderful. Okay, and can you all, maybe I would love if someone could say, can you read well this terminal here? I guess I could try to figure out how to make it bigger, like the text bigger if we needed to. But if anyone can't read that, please shout it out. Okay, Babu says we're all good. Excellent, excellent. Okay, so of course this package, because it uses both JavaScript and Vyper, ends up needing both of these things. But the first thing we'll do is Vyper. So sorry, the first thing we'll do is Node. So hopefully you have Node.js installed. If not, you're on Mac. I think you just do brew install Node, or just go to Google and search how to install Node.js on one of your various operating system flavors. I'm certainly partial to Unix and Linux myself. Anyway, once we're in this folder, we can simply npm install, and it will install all of the Node requirements. Yay. JavaScript is so fun. Great. Okay, so as that's working, the other thing that we're going to need to do is we're going to need to get Vyper. So definitely the audience of this workshop is targeted to be people who are more in the web development world, and so they're more used to doing things in JavaScript and maybe not so much Python. So the first thing that we're going to need to do that I'll give a background for in Python is, well, first of all, we need to install Python 3. But the other thing we need to do is create something called a virtual environment. So you can see that right here. Basically, virtual environments in Python allow you to create, it's similar to packages in NPM. So it allows you to install like one version of a Python package or a pip package in one thing, and another one in another folder, and not have those like sort of conflict. So this basically gives us our own little Python playground on which we may play. So that's going to be with this command. So we're going to call this virtual environment venv. Very original, I know. There we go. And if you don't have Python installed, probably if you're on Mac, if you have homebrew like brew install Python 3 will do it. Otherwise, just go to the Googles, the interwebs. I'm sure there's lots of wonderful people that are excited to tell you how to install Python. Cool. Okay, so we've just made this venv folder. I think by ls. We will see it right here. So this wasn't there before, but now it is. Wonderful. So this is going to be the playground in which we do all of our fun Python stuff. Note that if we didn't do this, these things would probably still work. But if you wanted to, for example, have two different two different projects you were working on, like say 2 different dapps, and one had a dependency on like an old version of Vyper because maybe you found some glitch or something. Vyper's very new, so it's definitely possible to find glitches. This would allow you to do that. Okay, great. So we have virtual environment. Now we're going to activate it. You can see here, just source venv/bin/activate. Oops, venv, not venc. Wonderful. Okay, so you'll see that this little venv appears. Note that if you did these steps out of order, you need to get out of the virtual environment to do npm install. So for some reason, this sort of messes up the paths if you don't. So if you ever want to get out of a virtual environment, just go deactivate, and that will take us out. You can see that we don't have the venv there anymore. Great, okay, but let's stay in it for now because we want to be in it. And the thing that we need to do is pip3 install Vyper. Woohoo, okay, so that's going to be going to the interwebs and installing Vyper. Excellent, well, it looks like I can upgrade my pip, but that's fine. Okay, so because a lot of people said, and hi new people, I see some more people arrived since we started off. The question that I started off with, which I'm very curious to you newcomers as well, is whether or not you've used Vyper before. So let me know in the chat because that will help me sort of tune this to you. Aha, personalized live. The joys of the real-time internet. Okay, but if we, okay, Matthias hasn't used it. That's good, that's good. Most of the other people hadn't, so that's great. So if we go to Vyper on the wonderful DuckDuckGo, by the way, you guys should all quit Google if you're in decentralization, DuckDuckGo. Oh my God, what an amazing tool. Okay, so if we go and Google Vyper Ethereum, we can see some background on it. So if you guys are familiar, with things like Salinity, Vyper has a few advantages. One, the Python syntax is pretty clean. The code looks pretty good. Another one is it's got more security features built in. So for example, we don't have to use safe math. which if you've ever played around with JavaScript, it's like crazy to me that safe, like, there's stack overflows by default, right? This is crazy. So Vyper has a lot of advantages. Like, there's many websites such as this one that you can check out to understand it. Okay, in any case, I'm trying to save that web page. In any case, it looks like we've installed Vyper. So now we should be able to just npm test. Let's see what happens. Aha. Okay, so note that we're doing the testing in JavaScript. And this is one of the key things that I'm going to be going over in this workshop again, is that you don't have to worry about like being very intimate with Python to use Vyper. You can actually use it with JavaScript. Okay, sweet. So we've got a bunch of green check marks here. That is a success. So we can see a bunch of fun stuff going on in this repo. We can see here, this is an interesting one, should have compiled the Vyper contract without errors. So we'll go over the code as how that happens. We also have a setup function that is called, and then a bunch of wonderful stuff related to the wonderful world of Plasma, which if you guys are interested in, I'm totally down to go over some of like the Vyper code that enables us to have wonderful, scalable off-chain transactions. Okay, cool. So we had all our tests passing. So that means that we have done this successfully. So if you're following along, congratulations, you have just run Vyper in JavaScript. Oh, amazing. Okay, but let's look at what the heck that actually means. So I'm going to open up in my IDE here. I'm going to open up this folder we just created, which should be, where are we? EDCON workshop, Plasma contracts. Excellent. Okay, we're here. Okay, so what are like the basics of things that you need to do to like test smart contracts in general? So the big thing that you need is you need to be able to deploy the contract to your testing environment. So we use Ganache, which is part of the Truffle suite. Note that Truffle itself is for testing Solidity, so we actually don't use that. And you don't even have to use Truffle to test your Solidity. You could do it this way too. But if you do it in Vyper, you need to be able to compile the contracts. Excellent. So what do we have here? A wonderful compile contracts.js. Aha! So this is the thing that actually compiles the contracts. So let me go ahead and make this a little bigger for you guys. Excellent. Okay. So what's going on here? So we can look at the top. We see we're requiring FS. That's the thing that allows us to write to the file system. We can also see here that we have this thing called compilation. Okay, so this is a requirement on this utils.js folder. So hint, 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 that's going to be an important piece of the puzzle. But at the core, we have this compile contracts function, which is exported here. So you'll see later on that the tests, or actually the setup, which is called by the tests, end up running this compile contracts function. And what it does in this file is actually very, very simple. All it does is it does the actual compilation that is outsourced to this utils.js, which we'll check out in a second. And it takes that and it turns it into basically a JavaScript file. So if you remember in the beginning, we went in this folder here and we saw, basically we saw this exact thing, but you'll notice that what this said here was actually like a string, like some text. So in place of that gets popped in the actual bytecode. Amazing. Right, so on to the next thing. Let's check out this utils.js to see actually what's being compiled here. Wonderful. So hang on, I'm going to move this down a little bit. I think you guys can see that, but I can't because my Zoom, my heads-up display is in the way. Okay. So here we have the actual meat and potatoes of what's going on. And we can see that literally what's being done in JavaScript is this exec function is being called, which basically does arbitrary like shell script execution. And all it does is simply call Vyper -f bytecode and Vyper -f ABI. So these are going to be the things that Vyper uses. So this is the thing that actually runs the Python, and it turns Vyper into native Vyper into some bytecode. And so of course we have the path here as well. And so you'll see that we just have this wrapper function compile Vyper. You pass in a path. So the path here is /contract/plasmachain.vy. Great. Okay. So so we can actually reconstruct this command in the terminal. So why don't we do that? Because that sounds fun. Okay, great. So here we are. Note that if we go to ls, we are in the same folder as utils.js. So that's going to be important because otherwise the path would be wrong. Wonderful. Okay. So literally what we're going to do is just show that this command is the exact command that's being run by the JavaScript, right? Which is kind of fun. So we see here the first thing is Vyper and then a space and then this path. So I copied the plasma chain Vyper file here. So we'll paste that in, -f bytecode. And ba-boom, look at that. So all this wonderful thing that is actually just a giant number is a special giant number that may be interpreted by Ethereum as a magical smart contract. Imagine that. So you can see this is a pretty simple command to run yourself, but you can maybe see why you also wouldn't have to run this command every time that you wanted to compile a Vyper contract. So instead of doing that, we literally just call it here, and that's great and wonderful and does everything we need to do. Okay. So let me go ahead and show you guys what this looks like here. If we go if we go to compiled contract, this is what we talked about before. So if we take a look at this file, we'll see module that exports equals bytecode 0615. Is that the same? Yeah. So actually, we should see here at the start of this file an 0615. Aha! Look at that. Okay. So we can see that that's what's going on there. Does that make sense to everyone? I would love a chat response if that makes sense. I'm happy to go into more detail. It's pretty straightforward. You're just using JavaScript to call this exact command that we wrote in the terminal. Great. Okay, so now we have managed to get our Vyper into a JavaScript file. Of course, it's really just a JavaScript variable and a big string, but it turns out that's all you need. Imagine that. Okay, so I'm going to go here now, and I'm going to go, are you connected to an Ethereum node in order to run the bytecode? Okay, so we've got a question from Guillermo. He says, are you connected to an Ethereum node in order to run the bytecode? Great question. So what we have done here is not really running bytecode, it's just compiling it, right? We've taken, so particularly, actually, maybe it would be worthwhile to show the actual Vyper file. So we see here we were doing this on contracts plasmachain.vy. So if I go here, contracts plasmachain.vy, this is an actual Vyper file. So that's a great question, Guillermo, because maybe I should have been showing you guys some Vyper contracts from the beginning. So if we look through this file, it's a pretty long file. There's a lot that goes into making Plasma the wonderful cryptoeconomic toolkit that it is. But we have things like deposits, and ranges as some structs. We have very notably here an ERC20 contract. So remember that all smart contracts are interoperable. So if we go to test contracts here, there's actually an ERC20.vy. This is quite literally an ERC20 standard contract written in Vyper instead of Salinity. Definitely wasn't me. Yeah, the author is listed here. You can find it online. This is a pretty standard file. Okay, but to more directly answer the question, all we've done so far is taken files like these Vyper files, and turn them into bytecode. Awesome. So Guillermo says he understands. That's great. The only other thing to note is that eventually, to actually run like the EVM on the bytecode, right? So to actually process Ethereum transactions, we do need to be running some sort of Ethereum node. So in this case, we're using something called Ganache, which is a part of the Truffle suite, and it basically simulates a blockchain on your computer. So let's look at that process. Great. So we're going to end up getting to this file here, setup Plasma. But for now, let's just look at the test Plasma, because this is the testing file. So again, when we ran all these wonderful green checks, which we worked so hard to make pass, you'll see here, for example, at the top, deployment, operator usage, serialization decoding. We can see things like deployment here, operator usage, serialization decoding, right? So this is the actual testing file where tests are being run. However, before we do that, we have a, by the way, the testing framework that we use is called Mocha. We use both, well, Chai and Mocha, actually. So if you're not familiar with this is a testing framework. It lets us test things by calling these wonderful describe and before and it should functions. So there's lots of wonderful stuff there. If you guys haven't checked out Mocha and Chai, I highly recommend you do it. But for this, it doesn't really matter. You just need to know that it's a way that we're using to test functions and call them. Great. So the real key, the real meat and potatoes of what's going on in this test is what we have right here, which is a setup plasma function. So you can see here that's being called on the setup object. And if we find the setup object, aha, it is right here. So setup is simply this requirement, which is /setup plasma. So why don't we take a look at that? Excellent. And again, as always, guys, ask questions, spam the chat. I don't mind. I would love it. OK. So here we have setup plasma.js. So this is the real like meat and potatoes of doing what we saw in these files here, and actually getting them into a Ganache sort of Web3 Ethereum world. Okay, so for instance, here we can see this is the section where we're setting up Web3 and Ganache. So I'll pretty much ignore that. There's nothing really much to it other than, you know, we're using truffles, so you can check out like this link if you're more interested in that. But it's pretty standard. The really interesting thing is going to be here in this function setup plasma. So if you remember before, this is the setup plasma function. It is in the exports right here. It is like the thing that's really doing the stuff that we care about. Okay, so before I dive into this code, I guess one thing that I should cover is basically what are the important parts of our plasma testing, because this is like a fairly complex bit of testing that we have to do. And so there's a few contracts that go into it. Particularly, we can see here, those contracts are something called the plasma chain, a plasma registry, as well as this ERC20 contract, which we use to test ERC20 integration, as well as this serialization library. Okay, so basically we need to take each of these Vyper functions, which are turned into these lovely compiled contracts, and we need to deploy them from their bytecode and API into smart contracts. So effectively, that's exactly what we do here. So you can see that the first step is that the compile contract is getting called. So again, if I go back to the test, you can see here right at the top, it says compiled contracts, saving them to /compiled contracts. So this is the actual call that's occurring here. That is the same compilation that we saw before. It's the same thing we ran in the terminal. Okay. So basically, there's like the structure here is pretty repetitive. So I'm just going to go over the setup plasma example. So in the setup plasma example, what we do is we find the serialization contract. So what are we doing there? We're literally getting a require on the serialization.js compiled contract. So quite literally, if I just open this up here on the side, again, we're just grabbing this bytecode. And down here, this ABI. So then we can see here we name ser bytecode and ser ABI as the contract.bytecode and contract.abi. So then, of course, we need to deploy it. And so for that, we're using Web3. So hopefully you guys are a little familiar with how Web3 works. But it's a pretty easy call to create a contract, just web3.eth.contract, so pretty simple. And let's see what we're passing into here. So the first thing that we're passing in is the ABI. And in fact, that's really the only thing of real relevance that we're passing in here. The other thing that we're doing is getting this ADDR, which we can see here is just the address. So we're just pulling the first wallet from Web3. It doesn't really matter who deploys this contract as long as it exists. So we are going to be deploying it from the first wallet's address. Excellent. So once we've sort of created the contract, we can see here we're just setting an arbitrary gas price. Of course, this is all funny money in our own computers, so we could make the gas price much bigger and feel like some real whales, some real crypto whales. But in any case, the next thing that we do is we deploy it, and of course the data that we pass it is the bytecode. So through these two calls, we're getting in both the ABI and the bytecode, and we're calling .send, and that is sending it off to the wonderful world of Ethereum, which in this case is just a simulated node by Ganache right in our terminal. Excellent. So we can see the same thing being done again here. For example, right here, this is the plasma chain contract, which we're just calling contract because it is the real meat and potatoes of plasma. And so that has a .bytecode and a .abi as well. Again, we're calling the same thing here. And then we're deploying it. Note that we're calling this one plasma. So one thing that is important to note here is that we have this ser here and we have a plasma here. And we see that these functions return a lot of stuff, but the most important ones is the plasma and the ser. So this is ser is short for serialization. Perhaps I should have just called it that, but oh well. So these are some of the most important things, because in here, in this plasma, right, which is created here, is the actual deployment of the plasma contract in the chain. And really the most important thing that that has is the address. That's like the really, really, really key thing that we have. Excellent. So where should I go from here? So one other thing to note here is that in this case, we do an extra function here, which is called operator setup. Okay, and so what does that mean? So basically, we have to, so in Plasma, this is a little specific to Plasma, but it's relevant because it's basically the initialization step, the constructor step that we use in Vyper. So when you create a Plasma contract, there's a special person called an operator, and they are the one that can submit these blocks. And those blocks are big blocks of transactions. And the point of Plasma, which I'm happy to talk about more if you guys are interested, is to take a bunch of transactions and turn them into one little block hash and put that into the contract or into the Plasma contract instead. And through that little short hash, people later on can prove that they own some money. So one of the things that we need to define is who is that person. So you can see we're calling on the Plasma contract, which has been deployed here. We're actually calling a method called setup. And in that, we're passing the parameters, an address, namely the same address that we did above. That actually doesn't matter, but we did make it the same address. So this is what we'll call the operator address. We're also passing in a way decimal offset. So we can, this doesn't really matter what this is. In fact, it's set to 0 right now. It's basically the number of decimal points of way per plasma coin. So like one plasma coin might be worth 1,000,000 way, let's say. In this case, it's worth 1 because it's 10 to the 0. In any case, the last one is the address of the serializer. So remember up here, we deployed the serializer. We pull out the address from there, and we send it to the contract. So why do we do this? Well, let's take a look. But in effect, it's because the serializer is nothing more than a library used by the Plasma contract to decode and encode transactions. And so it needs to know an address where that library has been deployed for it to make requests from. Okay, but the most important thing is that we're calling this function here called setup. And we're, of course, calling send on that, meaning we're actually sending the transaction to call the setup. Great, so let's look at the setup function just for funsies. Fantastic. Okay, here we are. So this is a big old contract, but I'm just going to Control F right over to setup. We can say there's an is setup bool here. Spoiler alert, we're going to set that to true with this call. Right, so here is our setup function. So if you're not familiar with Vyper, this is just a pretty standard function definition. This is a public function, which is important because if it was private, we couldn't call it with the .send that we used earlier. In fact, you know what? Let me go ahead and pull this over here so that we can take a look at it. Ha, fantastic. It's very crowded on my screen, but hopefully you can see it okay. So again, what was the call that we were doing? Aha, this was the call that we were looking at right here. Plasma.methods.setup. So this setup is the same as this setup. So if this was called setup 1, we'd have to call this setup 1, whatever. And we can see here that the arguments to that setup are the operator, which accepts an address. So again, we have web3.eth.accounts.wallet.address. We have this thing called the decimal offset, which is the way decimal offset here. It's called the ETH decimal offset here. ETH way, it's all the same. And then the serializer address, okay, which again is ser._address. Okay, so hopefully that makes sense to everyone. This is how, this is basically the core of the setup. And this is basically called to give us a real robust testing environment. So maybe other things to go over. We also have a setup token here. This is for setting up our test token, our ERC20 token that we've created. So that you can test moving ERC20s and not just ETH around in the testing environment. So we're calling very similar things with the setup, but again, we're returning the bytecode and ABI, and most importantly, the actual the actual address, the token contract, along with a few other things. And then the rest of this file mostly is helper functions, but we can see that the main exports that we care about are setup plasma and setup token. Okay, great. So why don't I pause here for a minute and ask if anyone has any questions, or even if this is just making sense to you. That would make me feel great if you said it. So it would be lovely, lovely to hear. Because I want to make sure that I'm doing this for you guys because we're live, and so the more interactive we can get, the better. So has this all made sense so far? Any questions with what we've gone over? So Totiz, sorry if that name pronunciation was incorrect, asks, can we compile/convert to Solidity? So this is a very good question. So fundamentally, Vyper and Solidity are two of the same thing. They are programming languages which can convert to bytecode. So it isn't the case that you can convert Vyper into Solidity, right? So Vyper is sort of meant to be written instead of Solidity. However, one very important thing is that they use, everything uses the same ABI, or Application Binary Interface. This is the thing that allows smart contracts to talk to each other. So maybe a great example of this is, I'm sure you guys are probably familiar with like a Solidity ERC20 contract, but again, I'll show this again. This is the same, interface as the ERC20 contract, but written in Vyper. So we can see here there's a request for the total supply. You can get the balance of a particular owner. Of course, transfer from, and approve are like the big functions if you're familiar with using ERC20s. So very interestingly, we actually have something here which we normally see written in Solidity and was written in Solidity first, but it's been rewritten here in Vyper. So definitely it doesn't make much sense to convert from Vyper to Solidity, but the good news is they all convert down to the same thing, which is Ethereum bytecode. And what that means is they can interoperate. So, we for example, in our Plasma code, the core of our Plasma library is written in Vyper. But what we're working on now is support for extensibility. So adding basically smart contracts and extra functionality on top of the smart contract. And that part, because everything talks the same language, this ABI, can actually use Solidity. So we can't really convert things or compile things to Solidity, but because both Solidity and Vyper compile down into the same thing, they can talk to each other. And you can even write a bit of both if you desire. So I hope that helps. Excellent. Okay. Yeah, absolutely. You're welcome. You're totally welcome. We can see other fun things here, mint and burn and all those wonderful ERC20 things we can do. Okay, so this is basically, that really concludes the meat and potatoes of like how we get Vyper to talk to JavaScript. So once we go up to the test Plasma level, which is right here, we can see again that these functions, this setup function that we just went over in wonderful detail, is just being called by our Plasma smart contract tests. So what does it actually mean? Remember that the Plasma here is like the actual contract, the actual deployment. So we, for example, expect it to exist. So that's very important, and all those sorts of things. But you can see here, the basic testing is just done in Web3. So the Plasma object is this contract object generated by Web3. So for example, the very basic thing in Plasma that the operator can do is it can submit blocks, right? And so block submission is the submit block method. So maybe if I go ahead and bring this over here so we can see both, we should see a submit block. Aha, here we go. Okay, so when we submit a block, this is the piece of code, and lo and behold, because of the wonders of the ABI, JavaScript understands that too. And so plasma.methods will have all of the @public functions in this Vyper contract. So right here, what we've done is we're submitting a block. We're submitting a dummy block hash, which in this case is just 0x00000. Spoiler alert, that doesn't have any transactions in it. But it does actually allow you to submit things. So there's lots of that. Okay, so Babu asks, is this project available somewhere? Yes, and I'm happy to take all and any questions about that. So this project is all available under Plasma Group, which is the nonprofit organization that I work for. So we have a lot of parts in here, a lot of repos. The one that we've been going over in this is the Plasma contracts repo. So github.com/plasma-group/plasma.contracts-contracts. That will give you all of this lovely stuff. Now there's a lot more that goes into Plasma. So for example, the simple example is once you see a submit block published here, the client needs to go and verify some properties about the block hash, for instance, that their transaction got included. So there's lots of other logic like that. If, for instance, if we go to burner.plasma.group, plasma.group is our website, we can see we actually have like an interface, like a UI that does that. So this synced here, what this syncing is doing is it's downloading the block hashes that have been submitted and sort of verifying some properties of them. So do you assert/result the test? So Mike asks, do you assert/test the submit block result somehow? How do I know my test went fine? So Mike is doing a great job of calling me out on some code. So really what I should be doing here is actually is indeed checking that something actually happens. So notably, there will be an error thrown by this test if, for instance, the submit block failed. So for instance, if this was a bytes 32 file, and because Web3 would throw, that would cause the test to throw. But in reality, it is probably worth noting that we really should be doing some sort of tests here, which would look something like the following. It would look like submitted block. So anyway, to answer your question directly, Mike, the answer is no, although we should be. And there's lots of other examples of like more interesting things that we're testing here. But if we want to do that, we could do something like await plasma.methods. What is the variable called? Block hashes. Block hashes. Is that the right? Equals new block hash. Yes, excellent. Next plasma block number. Let me check what that is set equal to by default. So if we called 1, so this would be actually a test that would check that the block hash is equal to dummy block hash. So dot call. So if we did this, then we would want to do something like assert or expect submitted block .to equal dummy block hash. Yep. So very good, Mike. You definitely called me out on that. I'm going to save this and push it, and we will have improved our test coverage. So thanks, Mike. That's lovely. But there's better examples of stuff in other sections. So maybe a good example of this would be deposits. So in Plasma, the way that things work is that oh, bye, Babu. Thanks. I'm glad to check out the recording. Thanks for joining. So the way that that Plasma works is you deposit some money into the contract, and it sort of holds onto that and stores the fact that you've deposited. So if we go here, in the Vyper file and maybe go to the top, we can see that there's a struct called a deposit. And this deposit has some variables associated. It has something called an untyped start. It has the depositor, the person who deposited, and it has something called the preceding Plasma block number, which is to say, if the operator has submitted 5 block hashes and then I deposit, my preceding Plasma block number would be 5. So when we test deposits, this would be a better example of what we're doing. So this is a test that should allow a first deposit and add it to the deposits correctly. And so we're depositing 50 way into the contract here. So again, we're calling await Plasma methods deposit ETH dot send. The value of the send is the size of the deposit, right? And we're calling it from this wallet address. And now we're checking something called the executable start, the deposit start and the depositor. So these two are the depositor here and the preceding, or the depositor here, and basically the untyped start here. So note that we dot call these to check that the variables have been set internally, and we assert that they're equal. So that is a great example of like maybe some more robust testing. Block submission is pretty easy. So we don't test it as well. But it's a great call out because everyone can always improve their tests, always. Okay, so that about wraps it up for me. I would love if you guys had any questions. I'd be more than happy to answer about Plasma, about Vyper, about anything else. I hope this has been super clear and useful. So chat away. I would love to take some questions.
Well, while everybody's thinking about the questions, I would like to make an announcement about our next workshop. Our next workshop will be on Plasma application, and it's going to take place on Sunday, March 3rd at 12 p.m. Sydney time. The workshop will be delivered by our mentor, Pon Chicharam. And during that workshop, you will learn the basics of Plasma Chain, how it works, and the use case from a high level. You'll explore what it takes to integrate to OMC Go network to achieve scalability for your decentralized application. We will explore OMG network APIs, documentation, client libraries, and a way to get you started hacking away during the hackathon. That workshop, just like this one, will be brought to you by CryptoChicks and LinkTime. And don't forget to register to the hackathon at edcon.io/hackathon. Now over to Ben, and looking to see if there are any more questions.
Yep, I don't see any questions at the moment. Oh, please share the link. Oh, that is a wonderful idea. So let me link you guys. So here is the Plasma Group contracts link. So this would direct you to the stuff that we've been doing here in Vyper. If you're interested, so we actually have a full end-to-end Plasma implementation. So if you're interested more generally in learning about how to do things like transact on Plasma, run your own Plasma chain, and all of that wonderful stuff, we also have the Plasma repo, which is basically the integration testing. So you can see here all of these lovely subfolders. Here's our Plasma contracts. Here's something called Plasma core, lib, et cetera, et cetera. So if you check that out, if you're interested in like more generally running Plasma. Okay, so we just got two more questions. One question is, can we use Vyper and Solidity in the same project? Yes, that is a great question. And we totally can, which is super exciting. So I don't have many examples of this code. I'm going to see if I can find an example as I speak. Ah, yes. Okay. So so there actually is, I actually do have an example here of an integration. So recently, my team was at ETH Denver, and we were working on some new stuff. And we decided that some of the new stuff we were working on was some new smart contracting stuff that we wanted to do with Solidity. We didn't want to bother with Vyper, but we still wanted to use the core Vyper contracts. So I'm going to link to this repo. Now, this is like very hackathon code, but if you're interested in checking out how Vyper and Python are integrated, this would be a way to check it out. So the meat and potatoes here is if we go, I think, into test. Oh, if we go into the Plasma contracts here, if we go to test Plasma, or actually, the setup Plasma will show this. So I'm doing this on the fly. Yeah, to answer Mike's question in the meantime, we do have a TypeScript client almost fully complete. I think we have a few more tests that need to pass, but we do have some awesome stuff written in TypeScript. I've not, however, done TypeScript with Vyper, which would be kind of fun. Yeah, and also we have a Plasma contributors link and Telegram. So, you know, after this call is over, or for anyone watching after the fact, t.me/Plasma contributors, feel free to join and learn about the wonderful world of Plasma Group Plasma. So I'm sorry here that I can't find. I hope this is sufficient for the person who asked about Vyper and Solidity in the same project. If you check out this code somewhere in here, you will find me using Solidity and Vyper at the same time. I'm not sure if it's here directly. It might be in the. I was definitely running a sleep-deprived all-nighter when I was writing some of this. So, spoiler alert. But I believe compile contracts here will get some of what we're looking for. In any case, why don't you ask that question in Telegram, because it seems more relevant and I don't want to hold everyone else up. So yes, to answer Matthias's question, one of the things that one of the cool things that we've been working on is making Plasma more extensible. And we've had a really cool architecture, which is this called a predicate, actually, that allows you to do it. So state channels on top of Plasma are tricky, but they're much more doable with this framework. In fact, I think if I go in this same folder, if I go to predicates, contracts, predicates, Lightning. So funny enough, we're crazy, and we decided for this hackathon project to do a Lightning integration. So believe it or not, we have a, albeit hackathon style, but it actually Lightning compatible payment channel implementation with some fun stuff here. So the answer, Matthias, in short, is yes. Stay tuned for some announcements from us around that coming soon, TM. But in the meantime, you can check out this code. Also, if you're interested in seeing how, if any of you guys are interested in seeing how Plasma works from like a very high level and don't want to be distracted by much of like the smart contract and Web3 stuff, we have a research folder here, Plasma Group/research. And this actually contains a pure Python implementation of like the way that we do our Plasma contract. So it's sort of like a simulation. It's not, nothing's actually running on the blockchain, but that makes the code a lot easier to read and sort of understand and reason about. Yeah, so we have a more thorough announcement about all that wonderful stuff coming soon. This actually uses a super new cool modular framework, which is these settlement contracts that allow you to do things like payment channels and multi-sigs and all that inside Plasma. So that's definitely something that you guys should all check out if you're interested. Yes, and it is definitely some awesome new research, Jinglan. All right, any other questions? Thank you guys all for hanging around. Definitely, if you guys are interested, you should totally join our Telegram. We have a very awesome community of people going, working on some fantastic stuff and, you know, hanging out, talking Plasma, all that jazz. Okay.
All right, guys, if there is no more questions, I would like to thank you for joining our workshop tonight and looking forward to seeing you again here on Sunday. I'm going to post in the chat our social media. Please follow us along and have a great day.
Bye, everyone. Thank you.
Bye.